All right, section 11.2 is on arithmetic sequences. It's just a special type of sequence that we need to be aware of. The two things you need to make sure you can do from this section is you need to be able to recognize an arithmetic sequence by its formula and also by its graph. The other thing we're going to talk about here also is I want you to be able to compute a partial sum or compute partial sums of arithmetic sequences. First thing you need to know in the red here, the definition of an arithmetic sequence. The sequence where each term has a common difference. So if the first term's A, the next term is going to be A plus D. The next term is going to be A plus 2D. Next term would be A plus 3D. And that would continue on. Okay, so there's always a common difference between your terms. So let me show you a real example here. So if I had a term, well, here's just an example. We got 3, 8, 13, 18, 23, and that would continue on. So you can look at that, you can see what the common difference is. Between each number, we're going up by 5s. We're starting at 3 and we're going up by 5 every single time. So if we wanted to write an equation that fit this, okay, we have our notation here. A of n is going to equal our first term plus whatever that common difference is, which is 5, times whatever term you're looking at minus 1. Okay, that would be an equation that fits this arithmetic sequence. Now this form right here, this equation that we have, that works for every arithmetic sequence we have. These numbers, the 3 and the 5, are going to change depending on where you're starting at and what your common difference is. But there is a general formula you can follow every single time for if you know you have an arithmetic sequence. And that formula is, make sure you memorize this, A of n is going to equal whatever your first term is. We'll just call the first term A, plus, I'm going to put the common difference after the n minus 1. Okay, so this formula right here is something that you need to make sure that you copy down and you understand and you know that if you see something that looks like this, okay, that's an equation for an arithmetic sequence, okay? You need to know what the first term is, you need to know what the common difference is, or you need to know some of this other information so at least you can maybe solve for those. Okay. One other thing about graphs of these types of sequences is the graphs will always be linear. Okay, your points will always form a line. Okay, so that's something you need to recall as well. So if you're looking at a graph and you got points that are lining up in a straight line, you know you're looking at an arithmetic sequence or the graph of an arithmetic sequence. Next thing I want to do is I want to do a couple problems here that you're going to see on some tests and quizzes coming up here in the future. So I'm going to switch here to a different slide. If you want to look in your book, this is the same example done on page 834. Okay. We're going to use that formula from the previous slide there to help us do this. So in this problem it says the 11th term is 52 and the 19th term is 92. We want to find the 1000th term in this arithmetic sequence. See how in here it tells us we have an arithmetic sequence? Automatically I know I'm going to use the formula that was given on the last slide. Let me write it here again for you guys. So here we can plug in some things that we know. We know that the 11th term is 52. Okay? So I don't know what the first term is. I don't know what the common difference is. But I know when n is 11, I get out 52. So I can write that in here. 52 equals, I don't know what a is. Okay? I also know here the 19th term is 92. So when I plug in 19 here. I don't know what A is, I don't know what D is, but I know I'm going to get out 92. So let's write that down. So I don't know what A is. I know N here, when I get out 92, it says it's the 19th term, so 19 minus 1 times D. So let's simplify this a little bit so it looks a little better. I can rewrite that to be 52 equals, I can combine these to just be 10D. So A plus 10D, and then the other one is 92 equals A. This will become 18D. You've done problems like these in algebra. Okay, this is a system. You can use elimination if you want to try and solve it. That'd probably be the best way. I'm going to go ahead and actually subtract the two equations. This is using elimination from algebra. If I subtract the two here, I get negative 40. The A is actually eliminated if I subtract, and over here I'll get negative 8D. So I can figure out what D is. If I divide by negative 8, I know that D is going to be 5. Okay. Then I got to plug that back in to figure out what A is. Change colors here. I'm going to go back up alongside of these. So I know now that D is 5. Okay, I can pick either of these two. Actually, go to these. I can pick either of these two, plug in 5 and solve for A, and then go back and I have my equation, and then I can plug in 1,000 for N and see what I get out. Okay, so let's solve for A. We got to solve for A. We got D. That's an important value we're going to use. We got to solve for A. So I know here 52 is going to equal A plus, plug 5 in there. So this is going to become 50. So that tells me that A has to be 2. Alright, so I got some important values here that I can use. Alright, that gives me just about everything I need to figure out what the 1,000th term is going to be. Alright, let me get a little more room here so I can finish out the problem. Alright, so I know here that if I want to find the 1,000th term, A of 1,000, I know A is 2, so I'm going to have 2 plus N is 1,000 if I'm trying to find the 1,000th term. 1,000 minus 1. D, remember we found, was 5. Alright, you'll work all that out. You get 2 plus 999 times 5. That gives you an answer here of 4,997. You can use your calculator there to figure that out if you can't do all that in your head. But that's your answer. Okay? That's the type of problem you're going to be expected to do on some tests and quizzes coming up here in the near future. All right? There's going to be a second part to this video. I'm going to stop it now. You can take a break, but make sure you watch part 2 on the partial sums of arithmetic sequences.